Hello friends, my name is Samad and I'm going to solve GATE 2021 Aerospace questions. So in this video you will find the answers of questions. Let's start. First question is, consider the differential equation. An equation is given and the boundary conditions are given. Okay, the solution to this equation is, so how to solve these questions. So actually you will see this equation is given. So we can solve this equation to, we have to change d2 plus 8d plus 16 y is equal to 0. We can change right like this, right? So now we have to solve this quadratic equation. D square plus 8d plus 16 is equal to 0, or d2 So this is very easy to get the root of the quadratic equation. Now the solution is y is equal to, actually y is equal to cf plus pi, complementary function plus particular integral, right? So right hand side there is nothing, right? Only 0. So it will be 0 to cf. So this, according to this, we can find our solution is equal to y is equal to c1 plus c2x into e to the power minus 4x. So actually d is equal to same, right? Alpha and beta is same, minus 4. So according to this, so there are the constant solutions. Okay, so we have y is equal to c1 plus c2x into e to the power minus 4x. So there are so many conditions according to the root. So according to this, I got finally this one. Okay, I know you have already studied this kind of quadratic linear differential equation. Now I got finally y is equal to, and then now y dash, that is differentiate of y is equal to minus 4 c1 e to the power minus 4x plus c2 e to the power minus 4x minus 4 c2x e to the power minus 4x. You can write this is the differentiation of this y. Okay, now we apply the boundary condition, because now we have y and y dash. Okay, for y, first boundary condition is y of 0. Okay, we'll write here y of 0 is equal to 1, which means y equal to 1 and x equal to 0. So 1 c1 plus c2 is x is 0 into e to the power minus 4 into 0. Okay, so finally this one is 0, so c1 is equal to 1, and from this we have dy by dx. 0 is equal to 0, that is y dash is equal to 0 and x is equal to 0, that is 0 is equal to minus 4 c1 e to the power minus 0, that is 4 into 0 is equal to 0 plus c2 0 minus 4 c2 into 0 e to the power 0. So if we solve this one and c1, we apply c1 is equal to 1. Okay, here, so c2 is equal to 4. Okay, now we have c1 and c2 value, right? So y is equal to c1 is equal to 1 plus c2 is 4x e to the power minus 4x. So we just give the value here, c1 and c2 here. Finally we got y is equal to 1 plus 4x into e to the power minus 4x. So this is my final. Okay, so according to option, you will see D is the right option. Next question is, your x, y is governed by the following equations. The nature of this equation is, so first of all, we have to know the equation, general equation A d2u by dx square plus B d2u by dx dy plus C d2u by dy square plus D du by dx plus E du by dy plus F u is equal to G. This is a general equation. Okay, so condition 1, if b square minus 4ac is greater than 0, so we will say hyperbolic. Second condition, b square minus 4ac is equal to 0, we will say parabolic. If b square minus 4ac is less than 0, then we will say elliptic. Okay, so now according to this equation is given. Okay, so here you will see the coefficient of A is 1, this one A, this one B, and this one is C, right? So A is equal to 1, B is equal to minus 4, and C is equal to 6. Remaining D you will not find dy by dx here, so D is equal to 0, E is equal to 0. Okay, so now, and you can see here, so you can find here F or G. So we need only B, A, B and C to get which is, I mean, this equation is following in which condition, hyperbolic, parabolic or elliptic. So now b square minus 4ac is equal to, b is equal to minus 4, that is 16, minus 4 into 1 into 6 is equal to minus 8, which is less than 0, right? So less than 0, that is b square minus 4ac is less than 0, that is elliptic. So B is the right option, elliptic. Third question is, consider the vector field V is equal to given and the field V is. So the condition is, if del dot V is equal to 0, which is called divergence free. If del cross V is equal to 0, it is called curl free. Now divergence V is equal to dou by dou x, 2x plus 3y plus dou y by dou y, 3x plus 2y plus dou y by dou z of 0. So this is dou y dou x, this is dou y by dou y. Okay, now let's differentiate this. So we will find 2 from this plus 2 from this is equal to 4. So we got divergence of V is equal to 4, which is not equal to 0. So this is not divergence free. Now curl V, curl curl V is equal to I j k dou y dou x, dou y dou y and dou y dou z. 2x plus 2y, 3x plus 2y, 0. So this is the vector. Now we will solve this one. Okay, so how to solve it is very easy. Yeah, 0 minus 0 minus a 0 minus 0 plus k 3 plus 3. Okay, so you can solve, and curl V is equal to 6k, that is 6 into k value is not given, so k is equal to 0 is equal to 0. So it is curl free, you can say. Because we got 0. So according to this, we have current free but not divergence free. That is B is the right option. Next question is, the figure shows schematics of wave patterns at the exit of nozzles A and B operating at different pressure ratio. So oblique shock expansion wave of the nozzles are given, and I have to know it is overexpanded or underexpanded mode. So if you know the what is overexpanded mode and underexpanded mode and what is the condition to apply in these, then you can easy to find out what is actually it is. So overexpanded nozzle, I will give you the little knowledge of this. Overexpanded nozzle is when P is equal to PA. Exit pressure is less than the ambient pressure. So this is the condition of overexpanded. If flow must not cross center line, so get reflected shocks, then expansion to match P, to match pressure. It is the condition of overexpanded. Flow must not cross center line, so get reflected shocks, then expansion to match P, pressure. This is the condition of overexpanded. For underexpanded, P is greater than PA and flow along center line must be parallel to center line. So we have condition for underexpanded and overexpanded, right? So according to this, we have option A, because first one is overexpanded, okay, and this one is underexpanded, because here you will see flow must not cross center line. Here you will see the flow is not crossing the center line, and so get reflected shock, then expansion to match right here. And here is flow along center line must be parallel to the center line. Here you will see flow along the center line, and after the reflected is parallel line, right? So it is the condition for underexpanded. And one more condition is PE is greater than PA for underexpanded, and PE is less than PA for overexpanded. So according to this two condition, this condition, the last condition, we can easy to find out A is overexpanded and B is underexpanded mode. So A is the right option. Next question is, the combustion process in a turbo shaft engine during ideal operation is. So if we study the combustion chamber Brayton cycle, so you will easy to find out. According to basic Brayton cycle, 1 to 2 condition is isentropic. So what is 1 and 2 condition? That is, this is the compressor, this is turbine, and here is the combustion chamber. Okay, so this is 1, 2, 3, and this one is 4. This is compressor, this is turbine. So 1 and 2 condition is isentropic compression, which is called adiabatic or quasi-static or reversible. Okay. So this is the condition for 1 to 2. 2 to 3. 1 to 2, this is 2. 2 to 3 during combustion chamber, we have reversible constant pressure heat addition. So obviously during combustion chamber we are adding heat also. Okay. 3 to 4 is isentropic expansion. And 4 to 1 is same, reversible constant pressure heat rejection, but here it will be the same, reversible constant pressure and heat rejection. Here you will see it is, so it is called isobaric constant pressure, which means isobaric. Okay, so now we have, according to this, option B is the right option. Okay, the combustion process, turbo shaft during ideal operation. So combustion chamber we have reversible constant pressure, that is isobaric. Okay, so B is the right option. So facts is, the turbo shaft engine is 30,000 HP horsepower, thrust to weight ratio of 1.82 over 100. Okay, and thrust to weight ratio is 1.8 to 100. This is the fact of turbo shaft engine. But for ramjet engine, you will see, for ramjet engine is like that. Okay, this is 0, 1, 0, 1, 2, 3, and 4. So 0 to 2. Okay. 0 to 2, 0, 1, and 2. 0 to 2 is isentropic diffusion. Where M0 or M2, M1 to M2, Mach number 0 to M2 is much less than 1, and 2 to 3 is constant pressure compression, that is isobaric, and 3 to 4 is isentropic expansion. 3 to 4, this one. So this is the condition for ramjet engine. Okay, isentropic expansion. That's it. Next question is, how does the specific thrust of a turbojet engine change for a given flight speed with increase in flight altitude? So we have the thrust equation is T is equal to mass flow rate, exit velocity minus flow speed velocity, VA ambient velocity. We can write rho AV VE minus VA, because mass flow rate is equal to density multiply areas and multiply velocity. So, and a specific thrust is equal to T by M, thrust by mass flow rate, right? Is equal to 1 plus F into V minus VA. So 1 F is the ratio of the mass flow rate to hot to gas, hot to cold. So we have to find out a specific thrust of a turbojet engine. Okay. So remember, Mach number increase with altitude increase for the same speed. If speed is same, so Mach number increases with altitude increasing. Mach altitude, it will increase like this. This is the graph for Mach versus altitude. If speed is same, means speed is given. Okay, that, which means V is equal to constant. But thrust will be decreased. Thrust will be decreased with the change in higher altitude. That is, thrust is decreased with when altitude increasing. Okay. Thrust versus altitude. The graph of this is like this. Now, as we know that the pressure is equal to gas constant formula is P is equal to rho RT if Mach number increases, Vm is equal to Mach number is V by A, local velocity by speed of sound. Okay, if speed of sound decreasing, Mach number increasing, right? And according to this, we can say specific thrust increasing. Okay, so final, I have one more graphs. Okay, let's should be decrease like this. This is altitude. So here we will see A, speed of sound, pressure, temperature, and density. Okay. So speed of sound, pressure, temperature, and density, that all are decreasing with altitude. Okay, and thrust is also decreasing. Okay, and Mach number is increasing. So finally, I have, so the option of this is A, increase monotonically. How does the specific thrust of turbojet engine change for a given flight speed with increase in flight altitude? So flight altitude is increasing and flight speed, that is v is equal to constant, is given. So it will increase monotonically. Okay. Now, next question is, how does the propulsion efficiency of a turbofan engine operating at a given Mach number and given altitude change with increase in compressor pressure ratio? So specific thrust and compressor pressure ratio, first increase and then decrease. Specific fuel consumption, SFC, versus compressor pressure ratio, CPR, first decrease and then increase. So first decrease and then increase, this is the right option. Okay. So propulsion efficiency is same as the graph of SFC. Next question is, a solid propellant rocket producing 25 meganewton, thrust is 5 for 150 seconds. The specific impulse of rocket is given. How much propellant is burned during the rocket operation? So I have to find out mass. T is given, thrust is 25 meganewton, time is given 150 seconds. So a specific impulse, IS is equal to T by mass flow rate, which is equal to 25 into 10 to the power 6, mega is 10 to the power 6 Newton. Mass flow rate means mass by mass upon time. Okay, and a specific impulse is given 2980. Remember the unit. Unit is given Newton second per kg. Okay. So according to this, I have formula this one. Okay, if unit is given Newton second per kg, if unit would be given, Isp is equal to T by mass flow rate by G. If unit is given second, in second, so we should apply this formula. Isp is equal to T by mass flow rate into G. Okay, but unit is given this one, so I will apply this formula. Now 2980, this one given, mass given, sorry, mass is not given, I have to find out. T is given 150. 2980 is equal to 25 into 10 to the power 6 divided by mass, and just take T here. T is given 150. Solve, finally we will get mass value. So mass is equal to 1.26 into 10 to the power 6 kg. C is the right option. The shape of a supersonic diffuser that slows down a supersonic flow to subsonic flow is. We have one formula, dA by A is equal to m square minus 1 dV by V. Area velocity relation. Area Mach number velocity relation. This is a very important formula to know. If you know the Mach number and the area, so you can easily find out which is supersonic diffuser or subsonic diffuser. Okay. So likewise, if you have this graph. Okay, and you know Mach is m1 is greater than 1. So what is this actually? Supersonic or subsonic diffuser or nozzle? So according to this, we can find out. Okay, we have the graph and formula. So m is greater than 1. That is m is greater than 1. That is positive. Okay, and area is given. Area is decreasing. First increasing. A1 is increasing. A1 to A2 it is decreasing, right? So it is decreasing. So this is plus. This is minus. So here we. So what should be here? Here must be minus, negative. So plus minus is minus. So both sides should be, no, this is equal sign. So both sides should be same sign. If there is negative, so there should be negative. If there is positive, there must be positive. So I already know this is negative, this is positive. So here should be negative. So if velocity is negative, that is velocity is decreasing. If velocity decreasing, we can say diffuser. Velocity increasing, we can say it is nozzle. So finally we come to know velocity is negative, that is it is diffuser. Alright, and m is greater than 1 and it is decreasing because velocity is negative, so m is less than 1, that is m2 is less than m1. Okay, so we can say this one is supersonic diffuser. Right. Okay, so likewise we can find out what is this. Okay, so if there is a m greater than 1, if m less than 1, so what should be this? So easily we can find out. Okay, if you know the velocity is decreasing, diffuser, velocity increasing, nozzle, and this formula. Okay, so now according to the questions, we have converging, diverging. These, because the shape of the supersonic diffuser that slows down a supersonic flow to subsonic flow, that is converging, diverging nozzle. Okay, converging, diverging diffuser. So this is the right option. This one, m is greater than 1 here. In short condition, m is equal to 1 at the throat, and finally m is less than 1. Okay. Next question is, uniaxial tension test is conducted in two different samples prepared with homogeneous isotropic materials. One of the material is brittle, whereas the other is ductile. So if you UT, the uniaxial tension test, if you take this test, so if we take the test on ductile material, okay, so it will form 45 degree, okay, and then it will break. But the case of Rudder material, it is perpendicular to load this surface. So this is for condition brittle material. Okay. So if you take, see, here is a tensile load is applying. So one of the material is brittle, whereas the other is ductile. Assuming that there is no stress concentration at loading point, the failure could be initiated along x-axis in the brittle material, because brittle is perpendicular to the surface. So x-axis in the brittle material, along y in the ductile material. So along y, this is 45 degrees given. So along y in ductile material. So this is the right option. Next question is, for the state of a state as shown in the figure, what is the orientation of plane with maximum shear stress with respect to the x-axis? So here sigma x is given. This is sigma x, this is sigma y, and this is tau xy, right? But you will see sigma x is direction is this side, that is negative, that is compressive. Sigma y is underside, that is negative also, that is minus 20, minus 80, and tau xy, it should be this side, but it is opposite side. So tau xy is equal to minus 30 megapascal. So there is a sign convention. Okay, if you know the sign convention, so you can easy to find out which one is positive or negative. But just for remembering, if sigma x is compressive, okay, if the compressive, we should put negative. If there should be tensile, we should put positive. Okay, but this is the compressive sign, that is negative. And tau xy, you can see this side. Okay, if it should be this side, so we should give positive, but here is negative. Now we have formulas. Orientation of principal stress. Okay, and we have one more formula. Orientation of maximum in plane stress, in plane shear stress. Tan choose theta s is equal to sigma x minus sigma y divided by 2 tau xy. So one is orientation of principal stress formula, and second formula is orientation of maximum in plane shear stress. So here we will see for the state of stress on figure, what is the orientation of plane with maximum shear stress. Here is given maximum shear stress, right, with respect to x-axis. So we will apply this formula. So negative sigma x is given minus 80, sigma y is given minus 20. So minus and minus plus 20 divided by 2 into minus 30. Okay, so tan 2 theta s is equal to, finally we solve this one, we will find minus 1, that is 2 theta s is equal to tan inverse minus 1, which is minus 45 degree. So theta s is equal to minus 45 divided by 2, that is minus 22.5 degree. So D is the right option, right? Next question is, let true airspeed VTAS is true airspeed. Okay, be the true airspeed of an aircraft flying at a certain altitude where the density VES is the equivalent airspeed. If rho naught is the density of air at sea level, what is the ratio of VTS by VES equal to? So VTAS is equal to mass flow rate, Mach number into A, speed of sound. It is the formula for true airspeed, that is Mach number into gamma RT, that is M into under root gamma R into rho by P by rho R, because the formula P is equal to rho RT. So we can write T. What is T? Sorry. So we have formula what is T. So T is equal to P by rho R. We can write like here. And then VTAS is equal to M into gamma P by rho. So this is also very important formula. And VES, same as VES, we can write M into gamma P by rho naught, right? So here is rho, here is rho naught. So now we know VTAS by VES ratio of this. Okay, so see, rho is inversely proportional to TAS. So rho should be inversely proportional. So even we can, just write here m in gamma p by rho divided by m into gamma p by rho naught. Cut, and finally we will get rho naught by rho. Okay, so this is the ratio of VTAS by VAS. Okay, don't mug up directly. Just know what is exactly. Okay, so the true airspeed velocity is directly proportional to Mach number and pressure, and indirectly proportional to density. So if you know this formula, so you can find the ratio of this or the ratio opposite of this, that is VES by VTS or Mach number relation, that everything you can find out. Okay, so according to this, we have C is the right option. Under root rho naught by rho. Next question is CM alpha variation for a certain aircraft is shown in the figure. Which one of the following statement is true for the aircraft? CM and alpha. Okay, moment coefficient and alpha is given. Okay, so we have one chart pitching moment coefficient, we can say, and alpha lift coefficient CL, or alpha, that is angle of attack. Sorry. So if, okay, here we can say this is nose up and here is nose down. This is aeroplane A, this is aeroplane B. If CM is greater than 0, we can say unstable. If CM, here is a CM less than 0, it is stable. Okay, it is stable. So this is the condition for CM versus alpha. I have CM versus lift coefficient, both are same. Because CL is equal to 2 pi alpha for 2D airfoil. Okay, 2 pi alpha. So it is a directly proportional. So according to this, we have B is the right option because the aircraft can trim at a positive alpha, but it is unstable. So this is the stability control topic, and it is a little difficult. If you don't understand these all things, then it is very difficult to find out. Okay, so CM alpha variation at a certain aircraft on the figure, which one of the following is true? The aircraft can trim at a positive alpha, and then but it is unstable. You can say CM is greater than 0. Go to this graph, it is unstable. Okay, but it can trim at a positive alpha. Okay, so B is the right option. Next question is, which of the following statements are true across an oblique shock or wedge shown in figure? So here is given statement is or are, that is more than one option may be true. Okay, and this is the shock. Okay, sorry, this is shock. Okay, now the flow is going like this, and due to this it is converted like this. Mach number is greater than 1. Here is the Mach number m2. If m1 is greater than 1, m2 is less than m1. Why? Due to oblique shock wave. Okay, or normal shock wave, it is same, little different, but because oblique shock depends on beta. Okay, oblique angle. So here is also pressure is going, temperature is going, density is going. So what is the condition before the oblique shock wave and after the oblique shock wave? So this is oblique shock wave. P2, here is condition 1, here is condition 2. Remember, m2 is less than m1. Rho 2 is greater than rho 1. P2 is greater than P1, T2 is greater than T1, but P02 is less than P01 total pressure, and T02 is equal to T01. These two conditions, these three conditions is same, and if M2 is less than M1, that is V2 is less than V1, obviously. Okay, so this is the condition for oblique shock wave. For expansion, this is condition 1, this is condition 2. For expansion wave, it is just opposite. M2 is less than M1. Remember, this is expansion, okay? Rho 2 is less than rho 1. Just remember, if M is greater, then density will be decreased. Density, pressure, and temperature also like this, okay? But here P02 is equal to P01 and T02 is equal to T01. These two conditions is very important because this, as you can see, it is changing here. Oblique shock wave, it is less than P02 is less than P01, and in expansion P02 and T02 is equal to the before and after the shock. Okay. Now this is oblique shock is given. Okay. So here you can find out total pressure decreasing. Of course, here you can see total pressure decreasing. Mach number based on velocity tangential to the shock decreasing. Mach number is also decreasing, and C. So here is given M, N, and MT, tangential and normal. Okay, so there are two Mach number oblique shock wave, and C's total temperature remains constant. So C is also the right, but Mach number based on velocity tangential to the shock remains the same. No, it is decreasing, and the based on velocity normal to the shock decreasing. So we have A, B, and C the right are the right option. D is wrong. Okay. Next question is, which of the following statements are true with regards to Kutta condition for flow past airfoils? So what Kutta condition says? So according to Kutta condition, there are 2 or 3 conditions. Okay, if you know that 2 or 3 conditions, so you can easily find. Even the conditions are given here, right? So it is utilized to determine the circulation on an airfoil. Okay, it is right. It is applicable only to airfoil with sharp trailing edge, and the trailing edge of an airfoil is a extraction point. No, and here there you will see in Kutta condition the trailing edge of an airfoil is not the extraction point. That would be smooth, and the flow leaves the trailing edge smoothly. D is the right option. So A, B, D. A, B, D are the right option. 16. According to the thin airfoil theory, which of the following statements are true for a cambered airfoil? According cambered airfoil, okay. According to thin airfoil theory, the lift coefficient for an airfoil is directly proportional to the absolute angle of attack. Lift coefficient is 2 pi alpha. It is directly proportional. The aerodynamic center lies at the quarter chord. Okay, C/4 quarter chord aerodynamic center. Okay, so A and B is the right option. The center of pressure lies at the quarter chord, no, and the drag coefficient is proportional to the square of lift coefficient. Drag coefficient, no. So only A and B are the right option. 17. Okay. Just take LCM. Okay. Our limit we will apply here. So limit extends to 0 is L hospital rule. Okay. We will apply L hospital rule. If we apply here x equal to 0, it becomes 0 by 0. So it is better to differentiate once more. 1 minus cos x after differentiating x cos x plus sin x. If here we will apply again, we will get 0 by 0. If x equal to 0, we will apply 10. Okay. So again we will differentiate. So differentiation of this is sin x divided by now if we apply x is equal to 0, okay, of where sin x divided by minus x sin x plus 2 cos x, right? If you apply here, so sin x sin 0 0, here also we will get 0 plus 2 cos 0 1, so 0 by 2 is equal to 0, so 0 is the right answer. Okay, next question is, given that, what is this? Zeta is the unit circle in the counterclockwise direction with its center and origin, the integral. Okay. You have to find out the integral zq 4z minus I dz, right? The closed integral zeta. So, we can write like this, zq divided by 4 z minus 1 by 4. Here we will apply z naught is equal to 1 by 4 and phi of z is equal to zq, this one. We just assume. So, the if we have counterclockwise direction with its center in the integral. So, if we have questions like this, so by Cauchy's integral formula, by Cauchy's integral formula, what it says, f of a is equal to 1 by 2 pi I c fz divided by z minus a dz. This is the equation for Cauchy's integral formula. So according to this we can apply. So 1 by 2 pi is not given, okay? So I is equal to, okay, 1 by 4 is constant. So we compare this equation to this equation, see. And 1 by 2 pi is not given, so we will multiply 2 pi I. And fz of phi z, okay, just assume here is fz is zq. We'll just write zq and in z is equal to 1 by 4, right? So 1 by 4 whole cube. Finally, we have 2 pi by 4 into 1 by 64, that is pi by 128. Round off 3 decimals, so pi by 128 is equal to 0.024 is the answer. Okay. 0.024. So if you know this formula, cross integral formula, we can easily integral this equation, this integration. Okay. Next question is, a single degree of freedom spring mass damper system is designed. Okay. I know the okay, how to find original undisturbed position in minimum possible time without overshooting. If the mass of the system m is given, spring is stiffness k is given, right? Natural frequency omega n is given. The coefficient of damping of the system is in Newton second per meter. So damping coefficient you have to find out. So here is given, what? Minimum possible without time, minimum possible time without overshooting. That is minimum possible time. It is only possible when it comes to critical damping. Okay. Critical. So over damping, under damping, and critical damping. Okay. So according to critical damped, we have damping ratio. That is equal to C divided by 2m omega n. So for critical, xi is equal to 1. Okay, and just talking about critical, not over damping or under damping. Okay, for xi is equal to 1. So if xi is equal to 1, C is equal to 2m omega n, 2 into 10 into 13.2 is equal to 264 Newton second per meter is the answer. It is 264 almost. Okay. Next question is, Two cantilever beams are made of same homogeneous material and have identical cross sections. Beam 1 has length L and beam 2 has length 2L. Ratio of the first natural frequency of beam 1 to that of beam 2 is. So we have formula omega n is equal to 1.875 square under root AI divided by rho A L to the power 4. Omega n is equal to directly proportional to 1 by L square. Okay, because we need only L value because there is only changing length, right? So according to this, we have given beam L. Okay, beam L1 is given L and beam of L2 is given 2L. So ratio of this omega n1 by omega n2 is equal to ratio of first natural frequency. So it is indirectly proportional. So omega n1 by omega n2, we can write L2 square by L1 square because it is indirectly proportional, right? So L2 is given L2 is given 2L, that is 2L square. Oh sorry, this is not confusing, BL1 BL2. Okay, beam of L1 beam of L2, 2L square divided by L square, right? So we can write like this and then finally we can get 4. So omega n1 by omega n2 is equal to 4 is the right answer. Next question is, a free vortex filament of a strength K is given, is placed at the origin and shown in the figure. The circulation around the closed loop A, B, C, D, E, F, A for this flow is. From Stokes' theorem, we know integration of any closed surface del cross C n dot dA is equal to 0. Okay, so for any closed surface, curl of C, it is a unit vector. Okay, so del cross C, the curl the any closed surface is equal to 0. So you can see here is the closed surface. Okay, and vortex is given this side. So the circulation around the closed loop, and circulation is defined by this formula. Okay, so closed surface circulation around the closed loop is 0. Then we will write 0. Even you can solve them manually 1 by 1, A to B, B to C, C to D. So finally you will get a 0 answer. 22nd is, a thin walled cylindrical tank with closed ends made of homogeneous and isotropic material is pressurized internally. If the hoop strain developed in the material is thrice the value of axial strain, that is hoop strain epsilon h is thrice of epsilon axial strain EA. Okay, this condition is given. So we have the formula EH, hoop strain, is equal to PD by 4T epsilon 2 minus mu, and EL is equal to PD by 4T epsilon into 1 minus 2 mu. What is mu? Mu is a Poisson ratio, right? So from equation 1, we can write EH equal to 3 into, so what is EL? EL longitudinal, or we can say axial. Okay, so from equation 1, PD by 4T epsilon 2 minus mu is equal to PD by 4T epsilon into 1 minus 2 mu, right? So this one cancel, this one cancel, we will solve this 2, finally we will get mu is equal to 0.2. 0.2 is the right answer. 0.2. Next question is, as that aircraft has a following specification: wing loading is given, wing area is given, drag polar is given, and maximum lift coefficient is given. Take density of air at sea level as given. The speed at which the aircraft achieves maximum endurance in a steady. So here is given maximum endurance in a steady and level flight at sea level is. So for maximum endurance, L by T max is equal to 1 by 2 under root Ct naught into K. This condition you will apply, and we have Speed at the aircraft is maximum endurance. Speed at maximum endurance, that is L by D maximum. Formula is, you know what? We have formula for this, 2W divided by rho CL. Okay, so here L is equal to W, level flight, which is the equation, 1 by 2 rho V square SCL. So for V, we can find this equation, and for maximum endurance, we can write 2 divided by rho is the density, and K by CD naught into W by S. Okay, this is the formula for L by D maximum. Okay. So what is under root K by CD naught? It is the CL, lift coefficient formula. We can write. Okay, we have drag polar, so we can write under root K by CD naught. So now we have everything. Like under root 2, rho is given 1.225, K is given 0.04. So this is CD naught, this is K. So 0.04 divided by 0.02. Now under root W by S is given, wing loading 1800. After solving this, we will get 64.467 meter per second. Okay, 64.467. Out of 2 decimals, we can write 64.47 is the right option, right answer. Next question is, an aircraft with twin jet engines has the following specifications. Okay, the rudder deflection, you have to find rudder deflection in degrees required to maintain a zero side slip at 100 meter per second in steady and level flight at sea level with a non-functional right engine is. So, yawing moment of the aircraft. Let's see, yawing moment. This is the yawing moment. Okay, yawing moment of the aircraft, M is equal to F into a span-wise distance divided by 2. That is 800 into span-wise distance is given. So here we will see, the wing span is given here and span-wise distance is given here. So don't confuse with wing span and span-wise distance. Okay, the span-wise distance is 10 divided by 2, which is 40,000 Newton meter. Okay, so finally we got M is equal to this, right? Now yawing moment coefficient Cm is equal to yawing moment divided by 1 by 2 rho V square S into B. B is wing span. Okay, is equal to 40,000 divided by 1 by 2, 1.225 into 100 square into 50 into 10, right? After solving this, we will have yawing moment coefficient Cn is equal to 0.01306. This is yawing moment coefficient. Now we have formula, Cn, yawing moment coefficient is equal to Cn alpha into alpha plus Cn delta R into delta R, rudder deflection, plus Cn beta into beta. So alpha is 0 because angle of attack, it is straight and level flight, so angle of attack is equal to 0, so this formula becomes 0. Beta, what is beta? Beta is the side slip angle, is also 0. Okay, only delta R, this equation becomes, so Cn I just found out 0.01306 is equal to Cn delta R. So Cn delta R is given 0.002 and into delta R, which is rudder deflection. So finally solving this equation, we will find out delta R is equal to 6.53 degree. What is this negative sign? Negative sign means aircraft falling downward or tilt left side. So it doesn't matter, we just apply 6.53. Okay, 6.53 is the right answer. Okay, obviously you can see C and delta R is given in degree. Okay, in degree, that's why finally directly we got degree. If they have been given radians, we have to change the radian to degree, and then finally I have to give value in degree, because here is asking in degree. So be sure and you have to care about the units. Okay, it is the misunderstand, and if you mistake in units, so you will get wrong answer. Next question is the velocity required to launch a space shuttle from the surface of the Earth to achieve a circular orbit of 250 km altitude is. The GM is given and surface Earth radius is given. So velocity is equal to under root G R square divided by RE plus H. This is the formula. Or we have one more formula, velocity required to launch a space shuttle. So we have to equate mv square by r naught plus small r is equal to G m into m divided by r naught plus r square. Okay, if we equate these equations, finally we get v is equal to under root GME divided by r naught plus r. Now we have all values, like GME is given 398,600.4 divided by r naught is given 6378.14 plus this r is given, that is nothing but the altitude 250. So 250 kilometer, and this one is kilometer, so all units are same, no need to change v. So finally v is equal to 7.75 kilometer per second. Okay, this is the answer. So how to get this equation? Okay, so this equation is the equation of centripetal force, and with the equation, the gravitational force equation. So if we equate this, and then finally we will get velocity. So it is the equation for the length of the rocket or shuttle, everything. Okay, anything we can. If you, and this is the velocity formula also. Okay, this is the gravitational force to gravity. So there are one or two more formulas. Okay, so if you study the rocket science, so you will find everything, this kind of formulas. Next question is, a rigid massless rod pinned at one end has a mass m attached to its other end. The rod is supported by a linear spring of stiffness k as shown in the figure. The natural frequency of this system is so this one is given, and so if this one if this one is vibrating like this, with this angle, theta angle, okay, and from here to here, this distance is s, right? So distance s is equal to, this s we can find under root h square, this distance plus total length is l, right? From here to here, it is l by 2 plus l by 2 l. So I have under root h square plus l square. I theta double dash is equal to minus k l by 2 theta into l by 2. Okay, now we have formula I is equal to ms square, is m h square plus l square. S is this one, okay, So we can write m h square plus l square of theta double s is equal to minus k by 4 l square theta, right? Or theta is equal to minus omega n square into theta. So now omega n is equal to under root, if we compare with these two, right? K l square divided by 4m into l square plus h square, right? And omega n is equal to 2 pi n. Omega n is equal to 2 pi fn. We have to find out fn, right? Because it is given according to fn. Fn is equal to 1 by 2 pi and omega n. So omega n value is this one, right? This value we will put here. So in option you will see 1 by 2 pi under root k l square 4m l square plus s square, that is A is the right option, right? 1 by 2 pi under root k l square divided by 4m l square plus, yeah, A is the right option. So likewise we can solve this questions. Next question is, the figure shows 3 glasses P, Q and R with water and floating ice. This is very interesting and important logical questions. Glass P has a solid ice cube. Glass Q has an ice cube with a small solid steel, right? Ball embedded in it, and glass R has an ice cube with an air bubble. After the ice cube melts, the level of water in glass P, Q and R respectively. So in P, when ice melts, the level of water remains same due to the ice block already displaced the water equal to its weight according to buoyancy theory. Okay, so if it will melt, so the water level will not change, it will be same. So this is one is same. Okay, what about Q? So Q, there is a solid steel given, okay, embedded in it, okay, in between the solid ice. So ice cube with solid steel ball. Here you will see, if it will melt, so this is the solid, it will not melt, right? It will go down, but this area already occupied, right? And it is melt. So if you consider this is the solid, whole is solid, okay, but it is melt and this one is not melt. So it becomes this area to this area. If you consider this one is also solid, this area to this area, so you will see water level will be decreased because the shape is changing from high bigger one to a smaller one, right? But about the ice cube with air bubble, if it will melt, okay, if it will melt, this is like this, okay. If it will melt, so this is bigger area, and if it melt, then air will goes up, right? It will remove. So from this area it will become this area, right? Because air is removed. So also here you will see the solid is changing larger one to a smaller one. So here also the water level will decrease. So it here decrease, here decrease. So according to this, option C is the right option. Okay. Buoyant force depends upon the density of fluid and the submerged volume of the body. So according to the submerged, you will see this one is same, this one is decreased, and this one will be also decreased, right? The buoyancy force formula is rho Vg. Okay, or we can write rho Ah G is equal to mg, this one, and rho volume, this is volume is nothing but area into height. Okay, h and g, or h height. So this is height, right? This height h is equal to m mass of ice divided by rho a. Okay, so according to this formula also it is verified that this. Now next question is, okay, so in this questions regarding the similarity of inertia and viscous force, that is Reynolds number are equal to Reynolds number of you will see here 1/5 scale model stretching the variable density wind tunnel. This is about wind tunnel and this is real. R is real. Okay. So we know Reynolds number rho Vt divided by mu of real is equal to rho Vt divided by mu of wind tunnel. Mu and mu here now you will see atmospheric pressure is given. Okay. We know that density is equal to Pm divided by RT. We just change density to pressure. Okay, M, R, and T. It is same. Okay, so density to P we can change. So P, Vt, and mu and mu cancel. So PVD of real is equal to PVD of wind tunnel, right? What is P? ATM, atmospheric pressure. Okay, so atmospheric pressure is given into V is the velocity, that is 100 km per hour, into D of real is equal to wind tunnel 10 times of atmospheric pressure into V into 1/5 of real model, right? dr is the diameter. Here you will see 1/5 scale model is tested in a variable, and you will see at 10 times the pressure used in wind tunnel is 10 times the atmospheric pressure. So we all set this equation according to the condition, and finally we can find out dr cancel, PATM cancel, and solve this. Finally we get velocity of wind tunnel is 50 km per hour. B is the right option. Next question is, the figure shows a schematic of setup for visualization of non-uniform density. Okay. So the figure is given. This technique of visualization of high speed flow is known as high speed, okay, which is known as shadow graph. Okay. So if you know these all things, then you can easy to recognize this is a picture of shadow graph. Next question is, for a conventional fixed wing aircraft in a 360 inverted vertical loop manual, what is the load factor at the topmost point of the loop? Assume the flight to be studied at the topmost. Here you will see N is, load factor N is equal to L by W. Okay, and if N is equal to 1, which means a straight and level flight. Bank, it depends on bank angle also. So if theta is equal to 0, N equal to 1, theta is equal to 45, N equal to 1.4. If theta is equal to 75, which will get N is equal to 3.9, which means theta is increasing, load factor is also increasing. But if the aircraft is flown in the right way up, it is N equal to +1, right way up. Okay, if aircraft flown is upside down, N equal to -1, upside down. So here is given inverted vertical. Okay, inverted means upside down, so it must be N is equal to -1, or we will see the topmost point of the loop. Assume the flight to be studied at the topmost point. So at the topmost point, N is always greater than -1. This is the right option. Next question is, which of the following statements is or are true about a function defined as fx equal to -x cos x for x is greater than 0. So fx is -x cos x, right? F dash x is -x cos x plus sin x. we differentiate this, right? So f dash of pi by 2 is equal to minus e to the power minus pi by 2. You know, fx is differentiated at pi, because if you see this graph, cos x graph, okay, this is pi, this is 2 pi, this is 3 pi, right? And this is pi by 2. So fx differentiated at pi, 2 pi, 3 pi, okay, and e to the power minus x and cos x both are continuous in R. So fx is continuous at x equal to 2 pi. So x is continuous at x equal to 2 pi. It is the right option. Okay. And fx differentiated at pi. B is the right option. 2 pi, 3 pi not, but it is not differentiated pi by 2 or 3 pi by 2. Okay. So B and D the right option. Next questions is a 2 degree of freedom spring mass system. Okay. From now we will solve this all question in video part 2. Okay.